Hi, welcome to the sixth form information presentation. This is for A-level physics. My name is Dr. Stephen Ball. I'm head of physics here at Abbey College. I've been here 10 years, so I've been head of physics for 10 years at Abbey. In my presentation, I'm going to talk a little bit about why we want to study A-level physics, what is in the A-level physics course, and some of the other things that we do for physics as well. Okay, so when I was doing this presentation, I asked some of my physics students why they wanted to study A-level physics. And a couple of people said, I wanted to understand the universe. Okay, so it's the idea of looking from the very, very small, i.e. the atoms, or the very, very large, which is the galaxies and so on. So we study all of those at A-level physics. Also, another student said that they wanted to do a lot of interesting practical work. So it builds on the practical work we look at GCSE and go even further at A-level. The physics content at A-level is very, very relevant to real world. It is interesting to teach, and more importantly, it's interesting to learn as well. It is a stepping stone to future study. So a lot of our students go on to study STEM-related courses at university. So things like engineering, engineering mathematics. We've had quite a few students in the past who have gone on to study theoretical physics, experimental physics as well. So this approach has led to a specification that hopefully will inspire students, nurture a passion for physics, and again, it's that important groundwork for future courses at higher degree establishments. So, the specification, well, at Abbey we do AQA, which builds on the AQA specification we do at GCSE. This is available online on the AQA website to download for prospective students to have a look at as well. This specification started in 2015, and actually when it comes to studying in 2021-2022, this will actually be the 6th year that this course is actually run. In terms of the breakdown of what we study every week, in the year 1, which is the lower 6, we get to study 5 periods of physics, each of 55 minutes lessons. And then in the upper 6, in year 2, we go from 5 lessons to 6 lessons a week. Okay. Each of those, there are 2 double lessons set aside, predominantly for practical work. Okay. We expect students to keep their own notes, their own ring binder, organise their home study and preparation, which is really important. The 5-hour rule is quite important as well, so students should be looking at spending 5 hours of study at home, okay, and out of the classroom. And that could be done for homework, it could be reading around the subject as well. Coming on to that, background reading is essential, okay, delving further beyond the classroom, looking at journals and so on, really, really important. As we said, there's lots of library books, there's lots of free online resources. So again, reading around the subject is really important at A-level. In terms of the content, most of this you'll see is probably familiar to GCSE. Okay, waves, mechanics, electricity, and thermal physics, they're all subjects we study at GCSE, but at A-level there are new subjects as well. So particle physics, we start that in one of the very first topics we look at is particle physics. So when students come in, they're actually starting a brand new subject and everyone's in the same boat. Okay, the first 5 subjects there tends to be year 1 subjects, subjects 6, 7 and 8 were taught in year 2. Okay, so they're a little bit, further mechanics, so the concepts are a little bit harder as well. There's also in year 2, we study astrophysics, okay, which is an optional topic. It's the one that we choose to do here. There are other option topics as well. And the 3 main areas of study for astrophysics are telescopes, classification of stars, and cosmology. Again, this is quite cutting edge work, experimental work. Cosmology certainly with dark matter and dark energy. but also looking at different types of telescopes. So students really enjoy studying the astrophysics option. Okay. In terms of exams, there are 3 exams taken for the full A-level course, which will be at the end of the second year. Each exam is 2 hours in length, and pretty much each exam is worth the same amount overall. So paper 1, 34%, paper 2 is 34%, paper 3 is 32%. Okay, so paper 1 tests basically the year 1 subjects, paper 2 the year 2 subjects, and paper 3 is slightly different because that includes practical skills, data analysis, and the optional astrophysics topic as well. In terms of the structure of the exams, it's a mixture of short questions, long questions, and multiple choice. Okay, so paper 1 has 25 marks multiple choice, and so does paper 2. There are no multiple choice on paper 3, but it's split between the practical skills and then 35 marks on the astrophysics. Obviously, we will do a lot of practical work as we go through. We'll talk more on that, but obviously we'll do a lot of exam preparation as well. In terms of entry requirements to study A-level physics, ideally you would need a minimum of a grade 6 in physics, and preferably a grade 6 in maths, but it's not obviously a prerequisite. If you are studying combined science, okay, then you will need at least a grade 6 in your physics papers. So the reason why we ask for grade 6 is because obviously the A-level needs to build on work that they've already done in GCSE. Okay. So coming back onto practical work, as I said, one of the double lessons a week is usually dedicated to practical work as well. There are no externally marked assessments for practicals, but what they will have to do is an endorsement. So there are 12 practicals, okay, that you have to do throughout the 2 years, 6 in the first year, 6 in the second year. And obviously you have to get some criteria to satisfy those. And also there are assessments as well, based on the practical, there's exam questions based on practical work. In terms of internal assessment, how do we monitor progress? Well, every week students get set problems. They could be mathematical problems, they could be past exam questions. Coming back onto the practical work, obviously there are write-ups to do. That could be write-ups for the practical, the required practicals, or it could just be a general write-up. When the topic is finished, we'll usually test them. So end of topic test could be twice a term. That could be part of a key assessment. Key assessments may be a full sit-down end of topic written test, or it could be based on some of the practical work we've done. Okay, and then in every January in year 1 and year 2, there are pre-public exams, the PPEs, and they'll follow either a full paper, which they will get in year 2, or in year 1, it'll be past exam questions. But it's not just all in the classroom. We do get to go out and visit other establishments. One of the trips that we tend to look at is Jodrell Bank, and that's really good for the astrophysics content. So we tend to go to Jodrell Bank probably once every 2 years. Here we get to see obviously the Lovell telescope, so we look at radio astronomy, but we also get to look at other things with stars and cosmology as part of our trip. Physics is still a popular choice. Okay, in 2017, the entries were nearly 30,000 for boys. There is a bit of a gap between the boys and girls. Okay, physics I think is still seen as a mainly boys subject. But again, girls in engineering and girls doing physics is, in the last 10 years, risen by nearly 2,000. So the girls are still doing it, and it is a popular challenge for girls as well. But it is overall quite a popular choice as an A-level. So if you've chosen to do A-level physics, what are the other choices that you can do as well? Well, probably the best combination was one that I did when I was doing my A-levels, was physics with maths and chemistry. It is not a prerequisite that you have to do A-level maths to do A-level physics, but it helps, okay? There is support on offer if you don't do A-level maths, but obviously when you're doing 5 periods of physics a week with a lot of maths content, that A-level maths boosts the maths up as well. So after you've done your A-levels, what do you do next? What careers are involved? Well, there's lots of careers. You just look at this chart here. Medical physics, meteorology, alternative energy seems to be very popular at the moment. It can go on in industry. Engineering is still probably the most popular choice for students to go and study after A-levels. So engineering, physics and other STEM subjects at university are really popular from the A-level physics. But again, what's a bachelor's degree worth of physics? So it could be anywhere between, let's say, £30,000, £60,000 a year. So again, it is still having a degree in physics after your A-levels is still a very popular choice and still can earn you quite a little bit of money. Okay, so that's my presentation. That's a little bit of A-level physics in a nutshell. If you'd like to know more, then obviously contact the college, contact me personally, and I hope I can answer any questions that you could have. Thank you for watching.